Hello and welcome to Note Quiz number 6, which is all about the transformation of functions. The goal of this note packet is to have us go through and look at how changing the function notation for a function is going to affect its graph. So the first thing we're going to do is establish a bunch of very important basic functions that we're going to be looking at for the rest of the semester. And so for the first one, it's the function f of x equals x. It's sometimes called the identity function because whatever you substitute or evaluate for this function, you get the same answer back again. Plugging in 0 will give you a 0, plugging in 1 will give you a 1, and so on. The graph is a nice diagonal line going through the origin at a 45-degree angle. So that's the graph of that function. The next function is called the squaring function, and it passes through the origin because 0 squared is 0, passes through 1, 1, because 1 squared is 1, and 2 squared is 4, and backwards, negative 1, 1, and negative 2, 4. So you get a nice graph of a parabola. And you're going to be seeing a lot of parabolas this semester, so it's a good graph to have in mind when you see an x squared type of function. The next function is x cubed, or called the cubic function. It also passes through 0, 0, and 1, 1, and this time passes through negative 1, negative 1. This graph kind of looks like a sideways S shape, or something like that right there. It should be noted that it goes up in both directions forever. The next point would be 2, 8, and then 3, 27, 4, 64. So for each x value, those values get very, very big once you raise them to the third power. The next graph is going to be the first time we see a restriction on a domain. It's a square root function. It also passes through 0, 0, and 1, 1, but now you have to go all the way to x equals 4 to get a value of 2. And this graph just looks like half a parabola. And again, you notice it's the first time we're seeing a restricted domain. The cube root function will pass through 0, 0, 1, 1, and negative 1, negative 1. And it looks just like our cube function from letter C, but instead this time it's rotated. So it looks something like this here for the graph. Kind of got sideways S, if you will. The absolute value function, that's going to look just like the y equals x on the right side, because it goes through 0, 0, 1, 1, and so on. But then it's going to, on the left side, come up like a V, because the absolute value of negative 1 is positive 1. So it's going to come up this way and give you a nice V shape with a sharp point at 0, 0. Finally, our last function to look at is the 1 over x function, sometimes called the reciprocal function. You'll notice that I cannot use 0 in that function because I can't divide by 0. So if I use x equals 1, 1 over 1 is 1. Then you'll notice if I take x equals 2, 1 over 2 is a half. So it's halfway between here. And then when I plug in 3, I get a third, a quarter, and so on. You'll notice those values all get smaller as I go to the right and get closer and closer to 0. Going towards the left, if I take a number between 0 and 1, like a half, and plug it in, I get a 2. Just like flipping a third is going to give me a 3. Flipping a 4 gives me a quarter. So my graph looks something like this right here. See if I can redraw that a little better. Okay, so again, it looks something like this. It's hitting a little funny on that little end piece there. Okay, I'll try it one more time. All right, so again, it comes down through here and goes that way. It also has a negative branch, which passes through negative 1, and it does the same thing. It comes up and goes that way. In the coming weeks, we will call that horizontal line, which is the x-axis, a horizontal asymptote. And we'll call the vertical line, which is the y-axis, a vertical asymptote. So these rational functions or reciprocal functions have a nice little set of new features that we haven't seen before. We've never seen asymptotes in this class, but we're going to be seeing a lot later on. All right, so the next thing for us to do is now look at how these transformations are going to affect our graphs. And we're going to first state them and then put them to use. If you are allowed to use a device like Desmos or a graphing calculator, you can also visualize these with those. But the idea for here is to talk about these from more of a classical perspective. So first of all, adding a number to a function is going to be a vertical shift because you're increasing all the y values. So when you have an f of x plus k, that is a vertical shift up k units. And the ordered pair, the x is going to stay the same, but the y is bumped up by k units and increased. Subtracting is going to lower it down. So this is a vertical shift down k units. So it's going to lower the position of the graph. Ordered pair becomes x comma y minus k. We now move on to adding and subtracting inside of the function itself. These are horizontal shifts, and they're actually the reverse of the sign that you see in the actual notation. So subtracting h is going to actually move the function to the right h units, and adding h is going to move the function left h units. So again, these are horizontal shifts, and this is going to be to the right h units. And the ordered pair is actually going to be x plus h comma y, because you're increasing the x's when you move it to the right. Again, the next one is a horizontal shift left this time, h units, moving to the left, and that's x minus h comma y. So those are the ones that actually pick up and move the function around. The next one are going to be resizing the graph. When you multiply by a number bigger than 1, it's going to shrink the graph or make the graph more narrow. We're going to say makes the graph narrow. And the ordered pairs is x comma a times y. When you multiply by a fraction smaller than 1, it's going to make it wider. This is going to make the graph wider. When you multiply the entire function by a negative, it's going to reflect it across the x-axis. So this is a reflection across the x-axis. It's going to take ordered pairs that have a negative y and make it a positive y, and ones that have a negative y, a positive y into a negative. So it reverses the sign of the y coordinate. We have two that are also used a little bit in algebra. The first one is going to be multiplying the inside argument x by a number that is going to compress the graph. And the other one is going to stretch the graph when you multiply by a fraction that is smaller than 1. And these would be us multiplying the x-coordinate before we evaluate the function. And finally, when you multiply the input variable by a negative, it's going to be a reflection across the y-axis. And that's going to have us reflecting the x. So it's going to be the opposite. So those are all of the transformations that we see in college algebra and actually the rest of math as well. Again, the most important ones are the horizontal and vertical ones because we do so much with them. The least common are going to be those compressions and stretches that happen inside of the function. The next thing to do is think about how we're going to put these transformations together, and you always have to follow the order of operations. In other words, you do what's inside the parentheses first. Inside the parentheses is always going to be your horizontal shifts and your stretches and your compressions. So that's going to be what we do first. The next thing we do is the reflections, either above the y-axis, x-axis, or both. And then finally, we do our vertical adjustments, either the stretching out, making the graphs wider or more narrow, and then moving them up or down. If you follow this order of operations, you will be very successful transformations. One of the worst things you can do is kind of ignore this and start just applying the transformations in any order you choose. When you do that, you get the wrong graphs. All right, so now let's putting these transformations to work by drawing some different graphs of familiar functions. And again, it's very helpful to refer back to that first page when you are graphing these kinds of transformations. So the first thing you always want to do, if possible, is identify your basic function. So this first function obviously is a absolute value because it has absolute values in it. And now you want to look at the formula and determine which transformations are taking place. And again, you'll notice there's two. We're adding a 1 inside of the absolute values, so that's going to be a horizontal shift to the left 1 unit. So we'll abbreviate. Again, that's a horizontal shift to the left 1 unit. And then we have a -2 or a subtraction of 2. That's going to be a vertical shift down 2 units. The next thing you want to do is fill in your ordered pair. So you'll notice that for the x-coordinate, it's going to be moving left. So we're going to subtract 1 from each of those. And the y-coordinate is going to be moved down 2. So we're subtracting 2 from the y-coordinate. We now fill in a basic function table using the first page of this. If I take a -1, a 0, a 1, and a 2, and take their absolute values, that's just a 1, 0, 1, and 2. So that's just filling in the basics from the first page, or just from your basic function up above. Now we're going to go through and take those x values and run them through the transformation. Again, the x-coordinate is decreased by 1. So every one of those x values is going to drop down by 1 unit. So -1 take away 1 is -2. 0 take away 1 is -1. 1 take away 1 is 0. And 2 take away 1 is 1. We're now going to take those y values from that table and subtract 2 from every one of them. So 1 take away 2 is -1. 0 take away 2 is -2. 1 take away 2 is -1. And 2 take away 2 is 0. So we now have 4 ordered pairs that we can plot, and we'll put those on our graph. First up is -2, -1. That's 2 left and 1 down. Then we've got a -1, -2. So that's 1 left and 2 down. Then we've got 0, -1, which is sitting down on the y-axis. Then we have 1, 0, which is up on the x-axis. Again, our basic shape is going to be the same. It's still a V shape. So my V comes down to there. And it's going to come back up over on this side. And you'll notice that the graph was moved 1 place to the left and 2 places down. And that's our transformations for that function there. Now let's move on to our next example, which is going to be a square root. So our basic function is f of x is equal to the square root of x. And this time around, we're going to have a total of 3 transformations. Again, it's always best to work from the inside out. So the first thing you're going to notice is because I'm subtracting 1 inside the square root, that is a horizontal shift right 1 unit. Then I'm going to multiply by 3, so that's going to stretch the graph by 3. So again, you're really multiplying the y values by 3 there. And then finally, we're going to, once again, subtract 2. And so in transformation talk, that is going to be a vertical shift down 2 units. So for our ordered pairs, the x is going to be impacted by moving to the right. Moving to the right means making the x's bigger. So that's x plus 1. Two things happen to the y values. They're multiplied by 3, and then they're dropped down or reduced by 2. All right, next thing to do is build our basic graph values. Remember, it's a square root, so there's restrictions. You got to have non-negatives. You can use a 0, a 1, a 4, and I'd say 9 is probably the last good one. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And again, those are just the basic function values that come from either the graph on the first page of the note packet or just plugging in those numbers into the basic function above. All right, now let's do our transformation. You will notice that the x's are all going to be bumped up by 1. So 0 plus 1 makes 1. 1 plus 1 makes 2. 4 plus 1 makes 5. And then 9 plus 1, of course, makes 10. The y values are going to be tripled, multiplied by 3, and then we subtract 2. So if you take 3 times 0 and subtract 2, that's just going to be a negative 2. If you take a 3 times 1 and subtract 2, that's just a positive 1. 3 times 2 is 6. Take away 2 is 4. And then 3 times 3 is 9. Take away 2 is 7. You will notice that that last number in the table has no chance of fitting on our graph, but we did want to compute it just to have it around. All right, next up, plot the points. So we've got a 1, negative 2, which is right here, 1 right, 2 down. We got a 2, 1, which is 2 right and 1 up. And we can squeeze in a 5, 4. So that's 5 units to the right and 4 units up. Remember, it's a square root graph. So it's going to look like half of a parabola going upwards towards the right. And that is the graph of our transformed function. All right, next up, let's move on to the last final page of this notepad. Let's first take a look at the top problem, which is a combination of a lot of transformations. There's 4 of them. First thing to do is identify the basic function. You should hopefully see that that's just the parabola, f of x equals x squared. All right, so f of x equals x squared is our basic function. If you look at our transformations, again, there's 4 of them. The first one you should see, again, is inside the parentheses. That is a horizontal shift left 2 units. Next thing we're going to see is we're going to shrink the graph by a factor of a half. So we're going to shrink graph. You can also think widen. Both are equivalent here. Next up, we're going to have that negative in front. That's going to reflect us over top of the x-axis. So we have a reflection across the x-axis. And then finally, we're going to add 1 to the function. That's going to raise it up 1. So vertical shift up 1 unit. All right, so now let's take a look at our ordered pairs. The only one that's affecting the x is going to be the horizontal. Moving it left 2 units is going to subtract 2 from the x's. And again, the y has got a lot going on. We're going to be taking half of it, multiplying by a negative 1, and then adding 1. So that's negative 1/2 times the y plus 1. All right, next thing to do is to take some nice numbers to work with. You will notice that because I'm taking half of all of my y values, I should start with even values of x, because that will give me a chance to take halves of nice even numbers. So rather than starting with like 3s and 1s and stuff, we'll start off with a negative 2, a 0, a 2, and a 4. Again, a negative 2 squared is going to be a 4 from the squaring. 0 squared is 0, 2 squared is 4, and 4 squared is 16. We now need to plug. All right, so now that we have our basic functions points found from, again, either the graph or using the function f of x equals x squared, we can now find our transformed points. You notice, again, all the y values are being subtracted by 2. So I'm going to take that x column of numbers and subtract 2. So if I take a negative 2 and take away 2 more, I get a negative 4. A 0 take away 2 is negative 2. 2 minus 2 is 0. And 4 minus 2 is 2. Now when you fill out your y column, be very careful to make sure you use the y's from the basic function. Common mistake is using the x numbers by accident. So I'm going to take a 4 and multiply by negative 1/2. That's going to give me a negative 2. And then if I add 1 to that, I'm going to get a negative 1. I now take 0 and substitute into negative 1/2 y plus 1. 0 times negative 1/2 is 0, plus 1 makes a 1. I'm now going to plug in 4. Half of 4 we know is 2. It's a negative 2 plus 1 makes negative 1. You notice it's the same value we got before because the 4's are the same. And finally, if we take a 16, half of 16 is 8 times negative makes negative 8 plus 1 makes negative 7. Unfortunately, we can't use that point to graph because it's way too small. Plotting our first 3 points, we've got negative 4, negative 1. We've got negative 2, positive 1. And we've got 0, negative 1. Oh, I gotta move that a little bit over. There we go. So 0, negative 1. So that's going to be the graph of a parabola because, again, this is the x squared basic graph. You'll notice that the negative did reflect it upside down. You'll notice that it's wider because of the half, and you'll notice that it's been raised up 1 place and moved over 2 places to the left. So graphing our parabola, we're going to get the following shape. And again, don't worry about being too precise with your graphs. The idea is to kind of capture what they now look like without, again, overthinking the points. All right, and now we'll move on to the most challenging of all the transformation problems. It's doing a transformation where there is no formula for the function. There's no computation. So instead what you have to do is go through the transformation step by step by taking the points from the graph and manipulating them. So here we go. First thing I would do in this case is write out the transformations that are happening. So you notice that for starters, it's going to be a horizontal shift. It's going to be to the right 1 unit, and that comes from the x minus 1. The next thing you'll know is we're multiplying by 2, so that's going to stretch out the graph, and it's going to basically double the y coordinates. And then it's going to be a vertical shift up 2 units. So we have to do that to all of our ordered pairs. So let's just move from left to right. First point we encounter is negative 4, comma, negative 2. I'm going to first shift it right 1 unit. So it's now going to be at -3 for the x-coordinate. I'm now going to take that -2 and multiply it by 2 to get -4. But then I'm going to add 2 to it to get -2. So that's my new point. Now let's take the next point on the graph, which is -2, 1, and repeat the process. First, shifting it right 1 unit is going to make it move to -1 for the x. And then for the y-coordinate, I'm going to double it. So 1 times 2 is 2. And then I'm going to add 2 to that and get 4. Now I'm going to take the point 0, -2. I'm going to first move it 1 place to the right. So that's now going to be at x equals 1. I take that y-coordinate of -2 and multiply it by a -2. So that's going to be -4, and adding 2 makes -2. You notice that it's the same height as the first one. And then finally, I'm going to move a 2, 1. Shifting to the right, it's going to bump that 2 up to a 3. And then I'm going to take that y value of 1 and multiply it by 2 to get a 2, and add 2 more to that and get a 4. So those are my 4 brand new ordered pairs. Starting with -3, -2, that's going to be right here, 3 left and 2 down. -1, 4 is 1 unit to the left and 4 up. And then I'm going to have 1, -2, so that's 1 right and 2 down. And then finally 3, 4 is 3 to the right and 4 up. Again, you will notice I have the same shape as before, but it has been stretched out and made taller, if you will. And it's been scooted over 1 place to the right and raised up 2 units. You will notice that you might be confused about the raising up of the 2 because the doubling or the multiplication by 2 made it stretch out. So you had 2 things working against each other. You had the stretching and you had the raising. So if we now connect our dots, we've got a blue line going up here, kind of zigzagging down to there, and back up to there. I guess that looks like the letter N if it's been kind of stretched out. All right, so that's our last transformation. Again, practice these because once you practice them, they're pretty straightforward and fairly simple, but they're really hard to do by cramming because it takes a little time for our minds to adapt to how to actually move these things around in the right way. So again, make sure you get plenty of practice so that you get good at moving graphs around using transformations.